Okay, so we're going to be continuing on with part B with the inverse formulas of integration. So there are three basic inverse formulas that you need to know. Many of them more are listed in the book, so we're going to go through them real quick. So if the denominator has a square root of 1 minus u squared, you can find the integral to be the basic form of sine to the negative 1u plus c. Also can be written as arc sine u plus c. This is the inverse sine. So same thing. If you instead of this you find 1 plus u squared, the basic form of this, it can be inverse tangent of u plus c. So both ways are acceptable. And then last one here is u times the square root of u squared minus 1 in the denominator. Find the integral of that. You would get the basic form of inverse secant of u, or arc secant of u plus c. Plus c in both, inverse secant. So let's take a look at an example that applies the inverse formula. So basically here we're finding the integral of 1 over square root of 9 minus z squared with respect to dz. So which one of these formulas does this most closely resemble? And it's probably this one, obviously. So inverse sine. So this is the basic format. So we need to make it look as similar as this as possible. So we factor out the 9 and get 1/3, and then it becomes 1 minus z over 3 squared. So then to get to the original sine inverse format, we make u equals z over 3, and then we factor out again 3 times 1/3 to be able to fully integrate this function with the 1/3 in the numerator. So then this is what we get, and then we're able to directly get to sine inverse sine of z over 3 plus c, which we talked about already. Can also be written as arc sine. Sorry, that's a little hard to read. Z over 3 plus c. Moving on. Logarithmic and exponential integrals. Again, there are many formulas for these, but these three are probably the ones we're mostly likely to use on the AP test. So du over u, that's the simplest one. Basically it becomes ln of u plus c. This is the basic form. So yeah, and then e to the power u du becomes simply e to the power u plus c, and this is a little more complex. A to the power u du becomes a to the power u over ln of a plus c. So let's look at an example that applies one of these formulas. Example 17. Integral of e to the power x over 1 minus 2e to the power x times dx, sorry, not times dx, with respect to dx, equals, so basically we're going to be going with this one right here, and at times this one maybe. So let's start. We factor out a negative 1/2 to get the negative 2 times e to the power x. Now, why did we do that? So our aim is to get to the integral for ln. So this is the function we're trying to get the integral with. So derivative of 1 minus 2e to the power x would be negative 2e to the power x. So that's why we had to factor out the negative 1/2. So quite simply, we can now make this into negative 1/2 ln of 1 minus 2e to the power x plus c. So basically all we did was we used the basic format of this, and we fixed the integral to make the du fit in the u so that we could take the integral of the function and achieve our answer. And that wraps up part B. Thank you.